The evolution of stars. The evolution of stars is a fascinating and complex process that spans billions of years. It is the story of how the universe creates the building blocks of life, from hydrogen and helium to the heavier elements necessary for planets and living organisms. The journey of a star begins with a molecular cloud, a vast collection of gas and dust that can span hundreds of light years across. These clouds are the remnants of past supernovae, and they contain the raw materials needed to create new stars. Within these clouds, gravity begins to pull together pockets of gas and dust, slowly creating a denser and denser protostar at the center. As the protostar collapses, it heats up, and the pressure and temperature at its core eventually reach a point where nuclear fusion can begin. Hydrogen atoms in the core combine to form helium, releasing energy in the process. This energy radiates outwards and helps to balance the force of gravity, creating a stable equilibrium known as the main sequence. The main sequence is the longest stage in a star's life, lasting for billions of years in some cases. During this stage, a star converts hydrogen into helium through nuclear fusion reactions. The amount of energy produced by a star is directly related to its mass, with more massive stars producing more energy than less massive ones. As a star ages, it begins to run out of hydrogen fuel in its core. This leads to a contraction of the core and a subsequent expansion of the outer layers of the star. The star becomes brighter and larger, and its color shifts towards the red end of the spectrum, giving rise to the name red giant. The outer layers of the star cool down and expand, causing the star to become less dense and its gravitational pull to weaken. At this point, the star is no longer in equilibrium and is no longer producing energy through the fusion of hydrogen. Instead, the helium in the core starts to fuse, producing heavier elements like carbon and oxygen. The star begins to shed its outer layers, forming a planetary nebula, while the core collapses inward to form a white dwarf. The white dwarf is a small, dense, and hot object that emits mainly thermal radiation. It is composed of electron-degenerate matter, a state of matter in which the pressure comes from the electrons, rather than the thermal motion of the atoms. The white dwarf slowly cools over billions of years, eventually becoming a cold and dark object known as a black dwarf. For stars with masses above 8 solar masses, a different fate awaits. These stars run out of fuel and undergo a series of explosive events, culminating in a supernova explosion. The explosion ejects the outer layers of the star into space, leaving behind a dense core known as a neutron star or a black hole. Neutron stars are incredibly dense objects that are composed almost entirely of neutrons. They are created when the core of a massive star collapses under its own gravity, squeezing the protons and electrons together to form neutrons. Neutron stars are incredibly hot and emit radiation across the electromagnetic spectrum. Black holes are the most extreme objects in the universe, with gravity so strong that not even light can escape. They are formed when the core of a massive star collapses to a point of zero volume and infinite density, known as a singularity. Anything that gets too close to a black hole is consumed by its gravity, making it impossible to observe directly. The evolution of stars has profound implications for the universe and life as we know it. The fusion of hydrogen in the cores of stars is responsible for the production of all elements heavier than helium, including the carbon, nitrogen, and oxygen that are necessary for life. The explosion of supernovae disperses these elements throughout the universe, making them available for the formation of new stars and planets.